3 like this, right? Like what I was doing like first I was doing comparator, and after that first I'm doing compare, and on this result I was doing something, maybe the syntax is wrong, but I was doing on this result I was doing then comparing with the second comparator, then comparing with the third comparator, right? I think looks like that is not working, and so this is the correct way to pass multiple comparators. Okay, first I'll show you the other example. Where is that? For example, I just have one comparator, okay? Assume that I just have only this comparator, and what I'm doing with that, I'm comparing with the employee name, and so that comparator I can pass like this, right? So this is one way. This we have already seen. Suppose if I want to compare with multiple fields, first write your comparators like with multiple fields, like and this is all employee name, but you can give any field like that. You give multiple fields with different comparators and pass all those comparators like this, like comparing. So here I'm doing first comparison I'm doing with the manager first name, the department, and manager last name. So basically I have 3 comparisons. So what it is doing, first it will get the result, and that result again it will compare with this, and that result again it will compare like this, and so totally this is your comparison reference. And if I pass this comparison reference here, then you will get the result. So if you see here, first I have written my comparator. After that comparator I pass to the TreeSet, and after that to the TreeSet I have added the values. Now I printed that. So if I execute this, so this is the manager set. So if we see the manager result, so first name. So let's see our comparison here. So first check with the first name, and so the first letter is P, next is R, next is S. So that is done. The next is department. So we have department, this one, admin A, C, F, F, I. The next thing is manager last name. are, so if you see here, so what is happening here? First I did with the first name, and after that the department name, and after that last name. So that is the reason you are not, though these three are start with the same name, but if you see here, C came first because before the last name I compared with the department, so that is it is sorted with the department names. After that it sorted with the last name. Okay, that is the reason. So you are not seeing A as the first. So if you see A as the first, then F will come here, right? So that is not correct. So because I was sorting, first sort with first name, after that sort with the department, after that sort with the manager name. That is why that is how it is filtering here. Suppose if I do like this, now instead of now you will see A as the first instead of this department. Okay. See now this department is not in the order. Only the names in the order. Okay. So that's about comparator comparable. Today we will talk about map. So we have already seen the different collection classes and interfaces available in collection framework, and so there are a couple of collection classes and interfaces which are implementing collection interface, and there are other part of collection classes and interfaces which are implementing map. Map is not implementing collection interface. Okay. So other classes and interfaces which are implementing map interface are like HashMap, uh, LinkedHashMap, what is that other one? IdentityMap, IdentityHashMap. WeakHashMap, map, same similar kind of classes. If you observe set, we have our set or list. We have HashSet, LinkedHashSet, SortedSet, NavigableSet, TreeSet. So in the similar way, if you see here also HashMap, LinkedHashMap, of course these two are different. SortedMap, NavigableMap, HashTable, TreeMap. So if you observe here, HashSet, LinkedHashSet, SortedSet, NavigableSet, TreeSet. Here also we have the same. Instead of set, we have map here. Okay, of course we have some other classes, but we'll see about this one. So in the set or list related classes, what we are doing, we are adding objects, right? For example, if I take list, what we have here, we have employee object. Okay, so what we are doing, we are directly adding objects, right? So like this, we are directly adding objects. Basically, the set or list related classes, those are representing group of objects, either same type or different type. When it comes to the map related classes, so it is not just taking objects. So here map is also, I mean, all the collection related classes all represent group of objects, but when it comes to the map related classes, so it is taking objects in the form of key value pairs, whereas in the list or set related classes it is just taking objects, directly taking objects, but map related classes it is taking key value pairs. For example, if I have the same employee, yes, so if you see here, so I told like it is taking as key value pairs. Now, so if you say list, here I have mentioned, okay, list, it is of type employee. That means it is taking only employee related objects. But here I told like as a map, which will take employee type of objects. But what it is saying here, incorrect number of arguments, it cannot parameterize it with arguments employee. So actually what it is taking these generic values as key value pairs. Okay. Now what I need to do, I need to say like some objects. I mean both key value pairs are objects only. So now what I am saying here, it is a map which will take key value pairs where key is integer, value is employee type object. Okay. Okay, first we will see like similar way, like list is an interface, and I am taking an ArrayList class. Here also I am taking map interface, which is the object of where I am assigning HashMap object to the map reference. You can take like this as well. Okay. So first we'll take instead of employee, first let me go with integer. Or let me take string. Okay, just for first we'll take with the basic integer strings, and after that we'll take the employee objects. So now I have created a hash map. Now I want to add some key value pairs to it. So where the key is integer and value is some string. So I'll add some key value pairs. So same way, like in the list or set related classes, if I want to add, I'll call add method. Right? So here it's not add, it's a put method. Okay. And what it is saying for the put method, integer is key, key is integer, value is string. Okay, now I'll say key as 1, value as some same some name. Okay, now if you see here what it is returning, it is returning some string value. So if you see here, it is returning some string value. Let's see what is that string value. Whereas if you in the list, if I add something, say for example new employee, what it is returning? It is returning boolean. That means whatever the object that we have added is actually added to the list or not. So it is just returning boolean value. Whereas here what is missing here? Here it is returning some string value. Let's see what is that string value. So it returned null. Okay. Now what I'll do, I'll add the same key value pair again. So you're observing here, right? It is returning null. Or let me keep the console here. Okay, it returned null. Now I'm adding the same type of key value pair. Okay. Now if you observe here, first time it returned null and second time it returned some name. I mean whatever the value that I have, let me change the value. Okay, now observe first time it returned null and second time I am passing with the same key but a different value. Okay, now if you observe here, it should print this one. Okay, okay, got it. Yeah, I mean that is correct only, but okay, let me print it. Okay, now if I print the map, then you will see actually we have added two, but if I print the map, then it will have only one. Okay, so what happened here? First, I have added one key value pair. Again, I have added another key value pair, but key is duplicated. So, what is happening here? Every time when you are adding a key value pair, it will check whether that key is there already or not. If it is there, then it will remove that and it will return the value. If it is not there, then it will just add to the map and you will just get written as return value as null. So when you add a key value pair and if you get a null value as a return value, that means that is successfully added and there is no duplicate key value pair. But if you get some value, that means the key value pair related to that value gets removed from the map and you will get that value as a return value. Okay, so that is the return type of put method. So if it returns something, that means that key value pair is there as a duplicate, so it will remove that and it will return that. If you get return value as null, that means it is successfully added to the map. Okay, so by this point, so basically map is also not allowing duplicate keys. But if I say like 2 and the same value, so in both the cases, we are getting null. And if you see the final map, you are seeing two key value pairs. Of course, value is same, but keys are different. So that means map is not allowing duplicate keys, but it allow duplicate values. Okay. So if I say null here, let's see what will happen. So it is accepted null value, null key as a value. Oh, sorry. It is accepted null as a key, and you're seeing the final output. Now, if I add another, so the same thing happened here. The way that is what it was happening for um, null, I mean duplicate key. Here also, if I add, if I am passing null as a key more than one time, if you see the final map, it is just having only two. So basically the previous one it removed and it just kept the latest value. Okay, that is the reason you are saying the return value as SAM. Okay, so basically it is accepting, it is not accepting duplicate keys, but it is accepting null as a key. Now we are talking about hash map, so that is accepting null key, but hash table will not accept that. Suppose same example, if you take hash table, so same example, if I take it for the hash table, so we are getting some null pointer exception. So what it is saying, the key is null, so that is why it is not accepting. So the null keys are not accepted here. Okay, and if you will see the other case, I'm passing duplicate keys. So this one also same thing. So if I pass the duplicate keys, it is removing the previous key value and it is just adding only the latest key value. Okay. Of course, there are few differences like between hash map and hash table. Like hash table, the objects are synchronized, whereas hash map, the objects are not synchronized. Performance wise, hash map is better when compared with hash table, and yeah, just now we have seen that hash table is not accepting null keys. whereas hash map is accepting null keys. Okay, those are the standard definitions. So now we'll see, now we'll go with the actual objects. Okay, now instead of this integer string, we will go with some objects. Okay, so now to this map, I'll add a couple of employee objects. Okay, so here we have different methods on hash map. Let's see that first. Let me take another hash map. So we have put method. Again, in the put also we have another method, that is, so to the map you can pass another map. So like put all. So that means what it is saying? It is saying map. So now if I say like put all, now I can pass this. In the same way, like to the list object, I am passing a collection, right? Like so list dot and I'm passing a collection add all, right? I can pass another list. The same way here you can pass another map like this. So now this hash map is having same objects as whatever this hash map is having. Now if you see the other methods, clear means it will just remove all the objects from the map. Clone, yeah, we'll come to this clone separately, basically it is just it's a kind of you can say it's a kind of Xerox. So it will just taking the same object as a separate copy. So contains key means maybe better I'll say, for example, contains key. So now I have a key as 2. If I pass this, then what it will show? Since because that key is there, then it will return that Boolean value as true. Suppose if I pass some scroll, that key is not there. So obviously it will say false. Okay, now let's see the other method. Contains value. So if I pass some object and if I try to search for that object, if it is there or not, then same way like a key. If it is exists, then it will return true, otherwise it will return false. So equals method, it is comparing with the existing object. Is empty, just checking whether that map is having any key value pairs or it is empty. Remove means if you just pass some key value pair and if that matches, then it will remove that and it will return the Boolean value. Replace means, so for a particular key, so right now for a key 2 I have this object. For a particular key 1 I have this object. Now I'll pass that key and I'll replace this object with another object. So integer key, employee and another employee. So it is replacing that. Size. Merge is it is merging two different maps. We'll see about this key set. Actually, the important methods here is that one we have seen this put all, and the next important methods in this is entry set, key set, value set. Those are the important methods here. First, we'll see. We have seen put all. Now, so here we have a hash map and we have added some key value pairs to it. So for adding a key value pair, we know that we need to use put method. There you need to pass the key value pair. Now I want to iterate the objects from the hash map. So how to do that? If you remember, for the class for the list or set related classes, we have seen different ways how you are iterating the list or set related classes and how we are getting the objects. So the similar way, but the map related classes also, you have the same you have the same type of ways, similar type of ways to iterate the key value pairs. Okay, so before talking about that, what we need to know about the entry set. Okay, why entry set means this key value pair, each key value pair is adding into the map as an entry object, entry set object or entry object. Okay, whereas if you take the list or set related classes, if you add an object, it is directly adding an object. There is no other extra type to it. Whereas to the map related classes, the key value pair, this whole thing as adding as an entry object. Okay, I'll show you that. For example, we have the while loop. Okay, let me. If it is a list, so what you are doing, you are calling the iterator method on the list. We don't iterator. Let me take map. Yeah, we have this entry set here. So let's take that entry set, which is returning set. And this we can call the iterator. So the iterator is returning iterator. For example, I have the iterator. So here itself it is showing that error. For list related classes, and why? So I'm comparing it so that every time I'm explaining by comparing list with map, so that because we have already seen with the list, so you will get some idea. So for a list, if I call iterator, then it is returning iterator object of type list, of type employee. Okay. Now here, if you observe here, first of all, we don't have iterator method directly on the map related classes. Okay, we have this entry set. So entry set means, so as I told, so each key value pair is adding into the map as an entry. We have a list of entries, entry objects adding to the map. So if you want to get those list of entry objects, you need to call entry set, because if you, I think it is not opening. One second. Yeah, maybe it's not opening. I need to. So what is missing? So I'll add it and. What it is saying, jrt.fsgr. Okay. Yeah, you're not seeing here, but actually this map is having another inner interface, that is entry set. Okay. Right now it's not opening in my Eclipse, but actually this map is having inner class. I mean, of course, that is also an interface, that is entry set. This is the inner interface the map is having. So we have already seen the inner classes, right? So in the inner classes, suppose I want to get access of any method of an inner class. What I need to do? I need to call like this, right? Upper class name dot inner class name. Then I can call the method, right? So this is how we are calling the inner class method. So in the map also, this entry set is inner interface to the map interface. Every time when we are adding a key value pair, it is going and adding to this object, to this reference, entry set reference. So all the key value pairs are getting added to this entry set reference. Now to get the values, we need to call the entry set, because that is the inner interface to the map, and that is where the key value pairs are getting added. So that is the reason we are calling entry set. Okay. Now this entry set, what it is returning? So if you observe here also, this is my upper class. Through the upper class reference, I am calling the inner class method, because if it is a static inner class, then you can directly call the inner class method from the upper class outer class reference. So I am calling this entry set from the upper class, outer class reference, what it is returning? It is returning set of entry, set of objects of type entry, and again entry is also with key value pairs, which is integer and employee. So I need to take like this. And this iterator, what it is returning? This is iterator of type entry, and that entry is key value pair of type integer and employee. So what I will take here, so what it is saying, import entry. Okay, so what is the wrong here? I think it's map.entry. This is correct only. Okay, spelling is wrong. So now I have this iterator. Okay, so what I did, I called the entry set method, which is returning a set of entry sets, entry objects, and I'm calling the iterator. So the iterator is returning like this. Now if I call, so we have different ways to iterate the key value pairs from the map. First we'll see with the while loop. So now actually we are calling the methods from the iterator, so the method names are same. So till here we are fetching the entry set objects from the map, and we are calling the iterator. So when we call the iterator, it'll return the iterator object. So from that the methods are same how we are calling for list or set. But only the difference is this entry. So each object is an entry, okay, entry object. So that is the reason we are explicitly calling it as an entry. So now here also has next and next. If you see here again, this next is also returning entry with integer as a key and employee as an object. Now I'll say this. Now Now what I can do, I can call the key, I can call the value from that. So get key and get value. So from the iterator object, I'm checking if it is having any next value. Go here, get that next value, and which is returning an entry object with key value pair. From that entry object, I am calling a key and calling value. So these are the key and value that we have added. So now we'll see if those 4 objects are coming or not. So we have added 4 key value pairs and we are seeing those 4 key value pairs. Okay. So this is one way that we are adding, we are iterating key value pairs from the map. Now we'll see a different way. So now what we'll see for loop. For the same thing, uh, so from that So here I'm calling this okay. Now I'll call this. Let me comment this one. So I'm calling the entry set, which is returning this map of entry. I mean, each time. So I mean, it's a for loop, right? So every time it will get one object, which is map entry object, and I'm getting the key value pair from that map entry object. So this is for loop. Now we'll do the same thing for what is that for each. Okay, now what I'll do, I'll call the for each method. For each method. So it is taking integer and employee type. Okay. For each key value pair. This is my key. This is my value. So here what is happening for each, I mean internally it is, I mean it is the same thing whatever we are doing here. Say for example, I'm iterating this this map, calling the entry set. Each time it is returning one key value pair, and I'm calling the key and value, and here also same. So for each time I'm getting one entry object with key value pair, and I'm calling those key value pairs. Let me comment this one. Okay, so it's the same thing. Now what I'll do, I'll call through streams. Let's see how we'll do that. So we don't have stream directly on this. We need to call entry set, and from that we have the stream. From the stream we have for each. So in the for each, now we have this consumer object, which is entry object. There is a slight difference between this one and this one, whereas this for each, if you see here, this is every time it is taking some key value pair, but here every time we have entry object. Of course internally it is a key value pair. Let me try that. I think this is right. Let's try that. Dot get key. Okay, here in the for each we are directly passing key and value, whereas here we are just passing that object, and from that object we are getting the key value pairs. Okay, so the same result. So these are the different ways how we'll iterate the map objects: for loop, while loop, for each, and again using the streams. Okay, so these are the different ways how we'll iterate. So far what we have seen, we are calling the entry set, and from the entry set we are getting the key value pairs. So in a similar way, you have two other options, like two other things like key set and value set. Okay, so basically, for example, if I take this, I want to get all the list of keys present in the map. So for what we have seen, we are just getting the entry set where we are getting the key value pairs, but I want all the keys present in a map. Okay, so for that, where is that key set? Okay, so key set is returning set of integers. Of course, integer means because that is the type that we have given for the key. So it is showing set of integers. Now, if I take set of integers, so if I just print the keys, okay, let me print the keys here. Okay, I have all the keys coming up here. Now, so I want the values based on the key. So what we can do, so while iterating while through for each itself, if I want all the values, okay, let me print the same. Um, value, right? So what I'll do, I'll call the get of key. So my key is now is k. Okay. And the same thing, whatever I was doing with the streams or for each or for or while, here also doing the same. But what I did first, I got the key set where I'll get the list of keys, and I'm iterating each key. While iterating each key, I am passing that key to the map, and so that it will return the value. Okay, the same thing. So all we have get all the keys and the values. Okay. So this is for your values where it is returning a collection. Now I have these values, and I can directly call the for each from the value, and it is now it's just an object, so employee object. So I'll straight away call that employee object. Let me remove this one, comment this one. So now what I did, I just fetch the values from the map. I'm iterating through for each. Each time I'll get a one object and I'm printing that object. Now if I print this, so we'll get the list of employees. Okay. So three things here. One is entry set, key set, and values. If it is an entry set, then you will get set of entries. Okay, so you can iterate those set of entries. Each entry you will get from each entry you will get key value, and you will get the key set where you will get the list of keys, and from that you will get if you want you can get keys, or if you want you can get the values for all those keys. And the third thing is you will just get the values from the map, and you can iterate it, and I mean we can do further action on those values. And we have seen different ways of iterating the map entries. I mean here we cannot say, of course it is an object, but we'll say better we'll call it as map entries, because each key value pair is representing as an entry object. Okay. So for hash table also it's the same thing. So except the differences, what is the difference that we have seen? This one, but it is not accepting null keys, but other than that it is the same thing. And same thing for linked hash map as well. Let's see for the linked hash map. So here also I'm saying some integer employee. So the differences are same here, like we have a list, linked list, and so why we are using I mean, what is the best scenario for use array list and linked list means, if your requirement is frequently on retrieving the objects, we can go for array list. So if your requirement is on frequently you are inserting or removing objects from different places from a group of objects, then it's better to go for linked list. So the here also same thing, because the main point here is when you say linked list or linked hash map, it is internally what it is doing, it is every object will have the reference to the previous object and to the next object, so that your insertion or deletion operation is fast because you know the address of the previous element and the next element. But that is not the case with the array list, right? So it will not have address of the previous element or the next element. So it has to shift all the positions of the existing elements to add a new element. So that is where it is taking time. So whereas in the linked list, since it is having the address of the previous and the next element, it will just change the addresses only for that, so that the operation will be quick compared with the array list. So other than that, there is no other extra difference, and the rest of the things are same. Like I'll add couple of objects to this. Okay, so I have added, and the next process is same. Like for example, let me take this for each. Okay, I mean the operations are same whether you take a hash map or linked hash map or whatever the classes that we have given here. Hash map, linked hash map, identity, weak, sorted map, hash table, tree map. For all these things, the process is same. The way that you are adding objects or inserting or deleting or iterating, the operation is same. So if you just practice with one thoroughly, then the rest of the classes it is the same syntax. Of course, there will be uh, each class will have its own advantages and disadvantages. I mean, it has its own features. Okay, now we will see another one, that is, what is this? Identity hash map. All the functions are same, but there will be few things which are different. We'll see what is the different now. I think we have already seen that example here. Take this one. First, let me create one identity hash map. For now, I'll just take integer and string. Okay, so let me add integer and string. For example, I'll add 1. And 1. So what I did, I have added same key value pair 2 times. Now if I print it, only one object came, and this one. So now also one came. Then what is the difference? So here instead of this one, so what I will do, I'll take for example, I'll take like this. Oh, that is deprecated, but I'm just taking this. You know this, right? If it is a uh, something is striking like this, then that means that is deprecated. So I mean that is no longer supported. So we not use that. Just for demo, I have taken that one, but in the actual implementation, if anything which is striking like this, then you cannot use that. Okay. So the main point here is, so in the previous case, what I did, I have taken, I have added 2 key value pairs where the key is duplicated. So when I print it, though it is identity hash map, when I directly print it, it is just removing the duplicate key value, and it is just returning the unique value. That is the first case. Now in the second case, what I am doing, I am explicitly creating an object, and I am passing those references. For example, okay, in the previous case, I have directly added the value key, and in the second case, I am passing references. So I is my first reference and I1 is my second reference, where I value is 10 and I1 is also 10. As per the map, if you give key value pair, sorry, if you give duplicate keys, what it will do? It will eliminate, it will remove the duplicate keys. Now what I did, I have taken 2 objects initialized with some value. Now I am passing those 2 object references, I and I1. Actually the value is same, but the objects are different, right? So internally what is happening, one object gets created and which is referenced with I and the 10, and in the second case another object gets created which is referenced with this is also referenced with 10. Okay, so now if I print it, as per the map rule, if you pass duplicate keys, then it should eliminate the duplicate keys. But now I pass the duplicate keys, but still it is returning duplicate keys. So what is happening? Every time when you are passing a key, we have two things, right? One is equals operator and equals method. Okay. So this equals operator, what it is doing, it is comparing the references. Whereas this equals method, this is comparing the content. Okay. Now in the map, what it is doing, it is comparing the references, because I is pointing to one object where the address is different. Say for example, assume that it has some hash code address. So you know that, right? Each object that you created, it will have some hash code value, that address. So assume that this address is address 1, this address is address 2. So when it is comparing the references, both are pointing to the different addresses. I is pointing to address 1, I1 is pointing to address 2. So since it is comparing the references and both are pointing to the different addresses, it is treating it as different key. Okay, because since these two are objects, these two are different objects, so it is just comparing the references, and it is treating it as different keys, and it is accepting them. Okay, so that is happening only for identity hash map. So if I take the same example for map or hash map, let's take the same thing for hash map. So this is a string. So whatever I was doing for identity hash map, I was doing the same thing for hash map. Let's print both identity hash map and hash map. If you see here, IdentityHashMap, it is taking duplicate keys, whereas HashMap, it is not accepting duplicate keys. So what is happening in the case of HashMap? HashMap is comparing the content. It's not comparing the references. Whereas IdentityHashMap, it is comparing the references, but not the content. Since the IdentityHashMap is comparing the references, both are pointed to the different addresses, so it is accepting the duplicate keys. Whereas HashMap, since it is comparing the content, here 10 both are same, so it will not accept the duplicate keys. So that is the difference between HashMap and IdentityHashMap. Other than that, the way that you are adding the objects, retrieving, everything is same. Okay, the next thing is WeakHashMap. Let's take that object. Example, I'll take employee. Okay, so what I'm doing, let me create one object. So assume that I have some values. Okay. So let me add this so I'm putting employee some okay. So now if I print it, so it is printing that employee object and with some name, which is fine. Now actually I have created an object here, employee object, and that object I have added to the WeakHashMap as a key. Now after adding that, I am removing that object. So basically I am setting with null. So that means what will happen if, so we are creating, so if you see this this whole thing, we have created multiple objects, right? We have created multiple objects, but when you are creating more number of objects, what is happening to that? Right? What is happening internally to those objects once you're done with your execution? So once we're done with our execution, there is a concept called garbage collector. So what it will do, it will identify the unused objects and it will destroy those objects. Okay. So what is meant by unused object? So any object, for example, right now take this thing. I have created an employee object. Now, so as soon as I created it, a reference name, this is my reference name, and this reference name is pointing to this object, where that object is having these values, right? Like to something. So this is my reference which is pointing to this object. Now when I set this reference with null, that means when I set, as soon as I set this reference to null, that means this reference is not pointing to this object. So now this object is hanging there, which doesn't referenced by any name, any object, any other reference. So this object is still there, but it is not referencing with anybody. So this is eligible for garbage collection. I mean, there are different ways, like what is the criteria that a particular object is eligible for garbage collection. So we can explicitly set that reference with null. There are other ways where it is eligible for garbage collection. So assume that this is one way. So when I set this, so now at this place, this object is eligible for garbage collection. Okay. So now actually what we did here, we have taken a hash map, weak hash map. Now in that weak hash map, I have created an employee object with some value, and I am passing that object as a key and with some value to the weak hash map. After that, I set that employee object with null. So that means now that is eligible for garbage collection. So now if I print this weak hash map, it is still there. I mean, now it is there, but actually it is not that as soon as we set it to null, it is eligible for garbage collection, and immediately the garbage collector is removing this object, right? Even if you call that a garbage collector explicitly, then also we are not sure that when it will remove this object, but it will remove this object at certain point of time. But the point here is, in the case of weak hash map, once you added some key value pair to the weak hash map, and any of those keys set with null, then you don't see that key value pair in the weak hash map, because that object that you are using in that weak hash map is eligible for garbage collection. Then that object will no longer available to use, so that in the weak hash map you don't see that object. I mean, right now we are not seeing, we are still seeing it, but it is not guarantee. Okay, I mean, we are not sure that as soon as you set it to null, it will immediately remove it. It's not like that, but it'll remove it. So that is the main point here. So when you are adding any key value pair to a weak hash map, and in that key value pair, if anything is eligible for garbage collection, then that object is no more useful, no more there in the weak hash map. But in the case of hash map, right, though the object is eligible for garbage collection, we can still use that object in the hash map, because we have already added that object in the hash map. You can still use it, but that is not the case with the weak hash map. After adding some key value pair, and if that key or value is eligible for garbage collection, then we cannot use that object from the weak hash map. That is the only difference. I hope you understand that. Okay. So other than that, the way that you are keeping objects or iterating, everything is same. Okay. So yeah, that's it for today. So we covered about HashMap, LinkedHashMap, IdentityHashMap, WeakHashMap, and we have seen how we are adding objects, how we are iterating objects in a different through different ways, like while loop, for loop, strings, and we have seen what is entry set, what is key set, what is values. But the main point here is entry set, key set, and values, and the other things are same, like how we are iterating the objects. The main point when you compare with the list and map is, while iterating in the list or set related classes, you are getting directly object, whereas here we are getting an entry. The entry will have key value pair, so there is one extra step here. Okay. Yeah, in the tomorrow session, we'll see about different other classes here, like SortedMap, TreeMap.
Yeah, okay, sir.
Yeah, thank you.
Thank you.
Bye.
Bye.